Hi everyone. This is Hemant. Today I'm here to explain about lexical analyzer. Now let us see about introduction to lexical analyzer. Lexical analyzer is the first phase in the process of a compiler construction. It involves converting a sequence of a characters into a sequence of a tokens. These tokens are used to parallel in the syntax analyzers phase to generate the syntax tree. A lexical analyzer, commonly known as a lexer, scans the input character and produces a stream of tokens for further syntax and semantic analytics. Definition and purpose of a lexical analyzer. Definition. A lexical analyzer or a lexer is a program that performs a lexical analysis. It takes the input source code and convert it to a tokens for further processing by the processor. Purpose. The primary purpose of a lexical analyzer is to simplify the subsequent phases of the compiler by breaking down at the input source code into a meaningful unit such as a identifier, keywords, and constraints. Now let us see what it does. Token recognition. The lexical analyzer defines and categorizes the lexemes within the source code, producing tokens as the output. Error detection. It is responsible for detecting lexical errors such as illegal characters or unrecognized patterns and handling them appropriately. Input to the processor. By producing a stream of tokens, the lexical analyzers provide the clean and organizes input to the processor for further processing. Components of a lexical analyzer. DFA tables. Finite automata are represented using deterministic state transition tables which derive the lexical analysis process. Lexical rules. These rules define the pattern of a token in terms of a regular expressions, guiding the lexical analyzer in its tokenization processing. Buffer. The input source code is a read character by the character, and a buffer is used to store a lexemes being constructed. Tokenization process. Lexeme identification. A lexical analyzer identifies lexemes based on the defined patterns and generates corresponding tokens. Translation in the automata. The use of a finite automata ensures efficient transaction between states, recognizing the token and token patterns accurately. Error handling. Any lexical errors encountered during the tokenization process are promptly detected and managed by the lexical analyzer. Regular expressions and finite automata. Regular expressions. These are used to define the patterns for tokens in lexical analysis. They provide a concise and powerful way to describe the set of strings to be matched. Finite automata. Finite automata are used to recognize the patterns defined by regular expressions. They provide a theoretical basis for the implementation of lexical analyzers. Error handling in lexical analysis. Error detection. The lexical identifies lexical error in the input source code. Error reporting. It reports the error along with the location and nature of the error. Error recovery. The lexical analysis attempts the recovery from the error and continues the tokenization of a process. Role of a lexical analyzer in a compiler pipeline. Input processing. The lexical analyzer processes the source code and code generates tokens which serve as an input to the subsequent phases in the compiler. Integration with a phaser. It seamlessly integrates with the phaser and to provide a validity and structured input based on the recognized tokens. Error propagation. Any lexical errors encoded are appropriately communicated to the higher levels of the compiler for handling and reporting. Examples of a lexical analyzer in programming languages. C compiler. The lexicon in the C compiler handles the tokenization of a C source code. Java compiler. Similarly, the Java compiler utilizes a lexical analyzer to process Java programs. Python compiler. The Python compiler includes the dedicated lexical analysis phase. Conclusion and a summary. Key point. component. The lexical analysis is a fundamental component of the compiler, ensuring accurate token extraction and error detection. Enhanced efficiency through the, through the use of a regular expressions and a finite automata, the tokenization process becomes more efficient and traces. Integrative role. Its integration with the compiler pipeline contributes significantly towards the overall process of the complication. This is the conclusion, the summary of this topic. Thank you.